The vanguard of space exploration is the rover. Well, orbiters and landers too, but rovers are especially useful. They can rove around and do science for us on the ground. They sing happy birthday to themselves. They're just great. We've roved a bunch on the moon and Mars, so we've got a lot of experience designing awesome science bots. But as we expand our exploration to other bodies in the solar system, we've got to make sure we have the right bot for the job. This is part of why NASA's Innovative Advanced Concepts Program, or NIAC, exists. The program's goal is to develop creative technologies that can have applications for future missions, even though the original projects themselves may not make it to space. None of the rovers we're going to talk about today are slated to fly anytime soon, but they provide all kinds of creative solutions to the problem of navigating new terrain. Imagine, for instance, putting a Mars rover on Saturn's moon Titan. Titan is so cold that methane and ethane, which are usually gases on Earth, are liquids there. And it's got lots of methane and ethane, so it's super wet, with tons of lakes and rain made out of the stuff. The Spirit rover got stuck in soft Martian soil in 2009. Imagine what would happen to it on Titan. The Super Ball Bot is designed to solve that problem. The bot is a NIAC project developed by the engineers at NASA's Ames Research Center in California. And it's totally different from any rover we've ever deployed. It looks more like a space-age tumbleweed. It's made up of a network of springy bars that form a kind of sphere, with its science payload sitting in the middle. The bars give Super Ballbot a property known as tensegrity in physics. Tension elements like springs connect the more solid parts like bars in a way that give the machine its structural integrity. Incorporating tensegrity into your design means you get a really rugged bot. It can take lots of impact, distributing those impact forces to protect its payload. Super Ballbot moves by rolling around and can climb up and down hills easily. And because it's quasi-spherical and lightweight, it can distribute its mass over a large surface area, which helps keep it from getting stuck in the mud. So it would be a great rover for a place like Titan, which is all kinds of hilly and muddy. Super Ballbot seems to have wrapped up development in 2015, but now that we know a tumbling rover can work, we could end up using the technology in future missions. Titan isn't the only place in the solar system with weird weather, though. There's also Venus. The planet's atmosphere has crushingly high pressures, is made of acid, and can melt lead. So obviously we super want to go there. That's why researchers are working on the Automaton Rover for Extreme Environments, or AREE. It's another NIAC project currently being developed at NASA's Jet Propulsion Lab, or JPL. Venus is such an extreme environment that the longest anything human-made has lasted there is 127 minutes. Back in 1982. Building a rover or lander that lasts more than a couple days would be a major achievement, mainly because computers do not like Venus. They overheat super quickly. But what if we could minimize the computerized aspect of the rover? Usually, computers control both the movement and the science, but what if they just controlled the science? That's the concept behind AREE. The rover will have high-temperature computers on board to be its brain, but it'll rely on the environment to move it around. AREE was inspired by an art exhibition that involved enormous wind-propelled machines. It just happens to be that in this case, the wind will be on another planet. The design means that if we do end up launching AREE or a mission like it, we won't have a lot of control over where it goes after it lands. But we've done so little surface exploration on Venus that we're basically guaranteed new, interesting data wherever we explore. Meanwhile, other researchers are working on rovers to explore other worlds below the surface. If we're going to send a rover to Jupiter's moon Europa, which we totally want to do, we're going to need a robot that can handle a subsurface ocean. Enter the Buoyant Rover for Under Ice Exploration, or BRUIE. The rover would float up against the water-ice boundary on a frozen body of water and use the ice as a kind of floor to move around. This isn't a NIAC project, it's run by JPL's robotics branch, but the basic goal is the same: to explore a new, out-there idea to see if it could potentially work for future missions. The team has been testing BRUIE in lakes with methane seeps in Alaska. These are lakes that vent methane from their floors because of some underlying geological activity, kind of like the lake version of a deep-sea vent. For now, it looks like BRUIE's excursions are all about design testing, but even the test environments could teach us a lot. Methane seeps in Arctic lakes have complex communities of extremophiles, microbes that can survive in extreme environments. So as BRUIE explores these lakes, we could learn a lot about some of the most unusual forms of life, the type of life we might find on other worlds if there's anything else out there. And ultimately, that's the goal with all these futuristic mission concepts. Developing them is a risk. It's expensive, and there's no guarantee the technology will work. And even though Super Ballbot, AREE, and BRUIE did work, they may never get to space. But it's what we learn in the process that's important, because someday we will send rovers to explore new worlds. And thanks to projects like these, we'll know exactly how to do it. Thanks for watching this episode of SciShow Space. If you're interested in more of the considerations that go into planning rover missions, you might want to check out our video about why the rovers we send to Mars don't study water.